Welcome back to this episode of partial differentiation. In this episode, we are going to learn how to find partial derivatives of first order. In episode 1, I had taught you the meaning of partial differentiation and different orders of partial differentiation. In this episode, we are going to pay our attention how to find partial derivatives of first order. If f of xyz equals to x cube y square z raised to 4, find partial derivative with respect to x, partial derivative with respect to y, and partial derivative with respect to z. Implies we need to find dou f by dou x, dou f by dou y, and dou f by dou z. First, let us find out dou f by dou x. When we are finding partial derivative with respect to x, we consider x as only variable and y as a constant. All y terms are constant and all z terms are constant. So dou f by dou x equals to partial derivative of x cube y square z raised to 4 with respect to x. This is equals to, we take out constant terms outside because we are doing derivative with respect to x. So y square is constant and z raised to 4 is constant. So partial derivative of x cube with respect to x. So this is equals to y square z raised to 4 and partial derivative of x cube is 3x square. Therefore, dou f by dou x equals to 3x square y square z raised to 4. Now, second case, we have to find partial derivative of with respect to y. So, differentiating partially with respect to y. While differentiating partially with respect to y, we treat other variable as constant. We treat x cube as constant and z raised to 4 as constant. So, only one variable, that is y square. So, dou f by dou y equals to partial differentiation of x cube y square z raised to 4 with respect to y. We take constant term outside of operation, that is x cube is a constant and z raised to 4 is a constant. So we took them outside of operation. Now left one is y square. So partial differentiation of y square with respect to y equals to x cube z raised to 4 and derivative of y square is 2y. Therefore, partial differentiation of f with respect to y equals to 2x cube y z raised to 4. Now, to find partial derivative of f with respect to z equals to partial differentiation of x cube y square z raised to 4 with respect to z. While doing with respect to z, other variables are treated as constant. In this, x cube is a constant, y square is a constant, and z raised to 4 is variable. So, taking constant term outside. So, x cube taken outside of operation, y square taken out of operation. So, partial differentiation of z raised to 4 with respect to z. This is equals to x cube y square and partial derivative of z raised to 4 is nothing but 4z cube. So this is equals to 4x cube y square z cube, that is partial derivative of f with respect to z. Example 2, f of xy equals to e raised to x square plus y square. Here, to find partial derivative with respect to x, we need to use chain rule. I want to revise here. Y equals to e raised to u. And if you want to find out derivative of y with respect to x, then this is equals to derivative of e raised to u with respect to x equals to e raised to u multiplied by differentiation of u with respect to x. This rule is called as chain rule. I would like to inform you, if your derivative is not strong enough, then please visit my playlist specially designed for derivatives. Come back. So f of xy equals to e raised to x square plus y square. Here u is nothing but x square plus y square. We need to use chain rule here. So dou f by dou x equals to partial differentiation of e raised to x square plus y square with respect to x equals to, first of all, e raised to u, that is e raised to x square plus y square multiplied by partial derivative of x square plus y square with respect to x. This is equals to e raised to x square plus y square multiplied by derivative of x square is 2x and derivative of y square, y being constant, derivative of constant is 0, therefore derivative of y square is 0. So the final answer is 2x multiplied by e raised to x square plus y square. Therefore, dou f by dou x equals to 2x multiplied by e raised to x square plus y square. That is partial derivative of f with respect to x equals to 2x multiplied by e raised to x square plus y square. Third example, if f of xy equals to 1 upon x square y, find partial derivative with respect to x and partial derivative of f with respect to y. Solution. So we have f of xy equals to 1 upon x square y. We know that derivative of 1 upon x with respect to x equals to minus 1 upon x square. Also, we know that derivative of 1 upon u with respect to u equals to minus 1 upon u square, and derivative of 1 upon u with respect to x is equals to minus 1 upon u square multiplied by du by dx. So this is a basic concept of chain rule. We are going to apply this rule here. So u equals to x square y. So partial differentiation of f with respect to x equals to partial differentiation of 1 upon x square y with respect to x. This is equals to u equals to x square y. So partial derivative of 1 upon u is nothing but minus 1 upon u square. That is minus 1 upon x square y square multiplied by partial derivative of x square y with respect to x. So this is equals to minus 1 upon x raised to 4 y square multiplied by 2x, and y being a constant will remain the same. This is equals to minus 2xy divided by x raised to 4 y square. This is equals to, here x and x get cancelled. So we get minus 2y divided by x cube. Even y get cancelled. So we get minus 2y divided by x cube y. Therefore, dou f by dou x equals to minus 2 divided by x cube y. Now to find partial derivative of f with respect to y. So that is dou f by dou y equals to partial derivative of 1 upon x square y with respect to y. Derivative of 1 upon u is nothing but minus 1 upon u square. So this is equals to minus 1 upon x square y whole square multiplied by partial derivative of x square y with respect to y. So this is equals to minus 1 upon x raised to 4 y square multiplied by x square being constant remain the same and derivative of y is 1. So this is equals to minus x square divided by x raised to 4 y square. X square get cancelled. So minus 1 upon x square y square. Therefore, partial derivative of f with respect to y, that is dou f by dou y equals to minus 1 upon x square y square. Example 4, if f of xy equals to log of x cube plus y cube to the base e. Whenever the logarithm questions are given to you, you always pay attention. Is it base e or is it base 10 or is it any other base? This is very important. Here is a base e and we are going to use the idea derivative of log u with respect to x. Log u to the base e with respect to x is nothing but can be obtained by using chain rule. Once again, derivative of log u to the base e with respect to x can be obtained by using chain rule. That is, derivative of log u nothing but 1 upon u multiplied by derivative of u with respect to x. So this logic, this chain rule we are going to use to solve these partial derivatives. So we have f of xy equals to log of x cube plus y cube to the base e. I read once again, log of x cube plus y cube to the base e. Here u equals to x cube plus y cube. Now partial derivative of f with respect to x equals to 1 upon u, that is 1 upon x cube plus y cube multiplied by derivative of u with respect to x, that is partial derivative of x cube plus y cube with respect to x. This is equals to partial derivative of x cube is 3x square and partial derivative of y cube with respect to x is 0 divided by x cube plus y cube, that is equals to 3x square divided by x cube plus y cube. Therefore, dou f by dou x, that is partial derivative of f with respect to x, equals to 3x square divided by x cube plus y cube. Now we will find out partial derivative of f with respect to y. So we have f of xy equals to log of x cube plus y cube to the base e. Now dou f by dou y, here u nothing but x cube plus y cube, and we know that derivative of log u to the base e with respect to x equals to 1 upon u into du by dx. So here we are doing partial derivative. So in place of d, dou will come. So partial derivative of f with respect to y is 1 upon u, that is 1 upon x cube plus y cube multiplied by partial derivative of x cube plus y cube with respect to y. This is equals to partial derivative of x cube with respect to y is 0 and partial derivative of y cube with respect to y is 3y square. So 0 plus 3y square divided by x cube plus y cube. Therefore, partial derivative of f with respect to y equals to 3y square divided by x cube plus y cube. Example 5. If f of xy equals to xy upon x square plus y square, find dou f by dou x. Whenever such question forms are given to us, you have to pay attention. We have to find with respect to x, that is the first question. Second observation, is this x variable, is it present in both numerator and denominator? So yes, the answer is yes. Once again, first question was, are we doing with respect to x? Yes, we have to find out dou f by dou x. So we are doing with respect to x. So answer is yes. Second question, is this x present in both numerator and denominator? Yes, x is present in both numerator and denominator, maybe in any form, but it is present in both numerator and denominator. If this variable x present in both numerator and denominator, then what formula we must apply? Answer is, we must apply quotient rule of derivative. That is, derivative of u divided by v equals to v derivative of u with respect to x minus u derivative of v with respect to x divided by v square. So to find out partial derivative of f with respect to x, we must apply quotient rule of derivative. So dou f by dou x equals to v nothing but x square plus y square multiplied by partial derivative of xy with respect to x minus u, that is xy as it is, multiplied by partial derivative of v, that is x square plus y square with respect to x divided by v square, that is x square plus y square whole square. This is equals to x square plus y square, and partial derivative of xy, y is a constant, will come as it is, and derivative of x is 1 minus xy, and derivative of x square is 2x, and derivative of y square 0, because we are doing partial derivative with respect to x, then y is constant, divided by x square plus y square whole square. Therefore, dou f by dou x equals to x square y, now opening all brackets, y cube minus 2x square y divided by x square plus y square whole square. This is equals to y cube minus x square y divided by x square plus y square whole square, which can be further simplified by taking y common. So we get here y square minus x square divided by x square plus y square whole square. This is required result for partial derivative of f with respect to x. That is dou f by dou x equals to y into y square minus x square divided by x square plus y square whole square. In this example, there are the two brackets. In first bracket, x square plus 1, in the second bracket, y square plus 1, and we need to find dou f by dou x and dou f by dou y, partial derivative of with respect to x and partial derivative with respect to y. So first we'll find out dou f by dou x. For that, write down the given function as it is, x square plus 1 and y square plus 1. Now we need to find dou f by dou x. To find dou f by dou x, there are the two brackets. So we have to decide what formula should we apply. Should we apply product rule of derivative or no need to apply? For that, you just keenly observe both the bracket. In the first bracket, x square plus 1. In the second bracket, x term not present. X term not present. Therefore, the second bracket totally becomes a constant. Therefore, to find partial derivative of f with respect to x, what do you do? Partial derivative of given problem, x square plus 1 multiplied by y square plus 1. Now y square plus 1 is a constant, so it has to be taken out of operation. So y square plus 1 taken out, then partial derivative of x square plus 1 with respect to x. Therefore, dou f by dou x equals to y square plus 1 as it is, and derivative of x square is 2x. Therefore, final answer dou f by dou x equals to 2x multiplied by y square plus 1. Now, to find out dou f by dou y, that is partial derivative of f with respect to y, equals to partial derivative of x square plus 1 multiplied by y square plus 1 with respect to y. There are the two brackets. We have to decide either product rule or no product rule. It is very clear that first bracket having only x terms, there are no y terms. So first bracket becomes totally a constant, and second bracket consists of y terms. So taking first bracket out of operation, then partial derivative of second bracket, that is y square plus 1 with respect to y, equals to x square plus 1, and derivative of y square is 2y and derivative of 1 is 0. Therefore, partial derivative of f with respect to y equals to 2y multiplied by x square plus 1.